We want to solve the following system of equations with the substitution method. We're asked to write the answers as ordered pairs. If infinitely many solutions exist, we enter the infinity symbol, and if no solution exists, we enter DNE. We will see each type in this exercise. So looking at our first example, notice how both equations are solved for y. So we'll take the expression negative 5x plus 13 halves and substitute this for y in the first equation. This will give us the equation with one variable of negative 5x plus 13 halves equals negative 8x plus 5. Now that we have an equation in one variable, we'll solve this for x and then perform back substitution to find y. Notice how we have x terms on both sides. Let's begin by adding 8x on both sides of the equation. So now we have negative 5x plus 8x, that's 3x, plus 13 halves equals negative 8x plus 8x is 0. That's why we added 8x to both sides. So then we have equals 5. Now we'll go ahead and isolate the x term by subtracting 13 halves on both sides. This is 0, so we have 3x equals, I'm going to write 5 as 5 over 1, so 5 over 1 minus 13 halves. To find this difference, we must obtain a common denominator, which would be 2. So we'll multiply 5 over 1 by 2 over 2. So now we have 3x is equal to, the denominator is 2. The numerator is going to be 10 minus 13, which is negative 3. And now from here, we normally would divide by 3, but because we have a fraction over here, let's think of this as 3 over 1. And instead of dividing by 3, let's multiply by the reciprocal of 3. So we'll multiply by 1/3 on both sides. Notice on the left, this simplifies to just 1x or x. On the right side, this also simplifies. We have a common factor of 3. This simplifies to 1. This simplifies to negative 1. So we have negative 1/2. So x equals negative 1/2. So for our ordered pair, we know the first coordinate is negative 1/2. And now to find the y coordinate, we'll substitute negative 1/2 for x. Let's go ahead and use the first equation. So using the equation y equals negative 8x plus 5, we'll substitute negative 1/2 for x. So we have y equals negative 8 or negative 8 over 1 times negative 1/2 plus 5. We can simplify here, a common factor of 2, that simplifies to 1, that simplifies to 4. So we have y equals, this would be positive 4 plus 5, which equals 9. So the y coordinate is 9. I did provide the graph here. Notice how the graph does verify our solution. The intersection point is here with coordinates negative 1/2, comma 9. So our solution is x equals negative 1/2, y equals 9, but we're asked to enter the solution as an ordered pair. So we have open parenthesis negative 1/2, comma 9, close parenthesis. Now let's take a look at our second example. Because the second equation is already solved for y, we'll substitute 8x minus 15 for y in the first equation. This will give us an equation in one variable. The equation will be x plus, again, we're substituting 8x minus 15 for y equals 6. Because we have addition here, we can just drop the parentheses. So we have x plus 8x minus 15 equals 6. If there was subtraction here, we'd have to clear the parentheses by distributing negative 1. Combining like terms, notice how we have 1x plus 8x, that's 9x, minus 15 equals 6. Add 15 to both sides, we have 9x equals 21. Divide both sides by 9. Simplifies to 1x or x. X equals 21/9, but we do have a common factor of 3. So x is equal to, what, 7/3. So the first coordinate of ordered pair is 7/3. To find the y coordinate, let's go ahead and substitute x equals 7/3 into our second equation here. So if y equals 8x minus 15, we have y equals 8 over 1 times 7/3 minus 15. I'm going to write 15 as 15 over 1. So we have y equals, this would be 56 thirds. Let's convert 15 to thirds by multiplying by 3 over 3. So we have minus 45 thirds, which would be equal to 11 thirds. So the y-coordinate, or the second coordinate, is 11 thirds. Looking at the graph of the two lines, notice how this does verify our solution. 7 thirds is 2 1/3. 11 thirds is 3 2/3. Going back to our first slide, let's record this. 7 thirds, comma 11 thirds. We do need the parentheses here. Now let's jump to our third example. Now here, because the first equation is solved for x, we'll substitute 4y minus 11 for x into our second equation here. This will give us the equation in one variable, which would be 3 times the quantity 4y minus 11, and then minus 12y equals negative 33. Now we'll solve this equation for y. We'll distribute here. So we have 12y minus 33 minus 12y equals negative 33. Notice here when we combine the like terms, 12y minus 12y is equal to 0. So the variables are now gone and we're left with negative 33 equals negative 33. Now this is always true, which means we have an infinite number of solutions, and graphically, if we were to graph these two equations, we would get the same line twice. So the lines coincide, so they have an infinite number of points in common, and therefore we have an infinite number of solutions. So for our homework, they ask us to enter the infinity symbol if we have an infinite number of solutions. From the keyboard, to access this online, you can use the equation tool or enter 2 lowercase o's. And then if you click preview, it will show the infinity symbol. Now let's take a look at our last example. Neither of the equations are solved for x or y, but looking at this second equation, notice how we can solve this pretty easily for y by adding 1/4 x to both sides. So let's rewrite the second equation as y equals 1/4 x plus 7. And now because the equation is solved for y, we can substitute 1/4 x plus 7 for y in the first equation. This will give us an equation in one variable which we can solve for x. The equation would be 8 times the quantity 1/4 x plus 7 equals 2x plus 21. Now let's clear the parentheses by distributing. Well, 8 times 1/4 x would be 2x, so we have 2x plus 8 times 7 is 56 equals 2x plus 21. Notice here we have x terms on both sides of the equation. Let's go ahead and subtract 2x on both sides. But notice when we do this, we have 2x minus 2x on the left, which is 0, and we have 2x minus 2x on the right, which is also 0. So the variables simplify out, and we're left with 56 equals 21, which you know is never true. So when the variables simplify out and the resulting statement is false, that means we have no solution. Our graph does verify this. Notice how if we were to graph these two equations, the two lines would be parallel, which means they never intersect, and therefore there is no solution. For our homework system, when there's no solution, we're asked to enter D and E. I hope you found this helpful.